So after studying the definition of relation, next is types of relation. So these are the types of relation. First up, which is empty relation. So consider one set having 1, 2, 3, 4 as its elements. Okay. Now, if question is saying that you have to set up a relation in which the ordered pair AB has a relation that the difference between these two numbers is 10. Okay. So what can you think of? Can you write it in rows to form? For example, if you have to get the difference which satisfies, so 1 minus 2, if you take ordered pair 1 comma 2, that means it should be, if it is following relation R, then it should be 1 minus 2, which is minus 1, which is not equal to 10. So it is not satisfying this relation, right? The condition of this relation. So if it is not satisfying, that means it is an empty relation. There is no ordered pair. Similarly, if you have universal relation as the name suggests, each and every element and the relation between the elements will come under this category. For example, if I tell you that there is another relation R dash where the ordered pair is having a relation when the modulus of the difference is greater than or equal to 0. Okay? Now tell me, can this will be satisfied using a set? If you consider 1 minus 1 with the ordered pair 1 1 or 2 2 or 3 3 or 1 2 or maybe 3 4, what it is giving you, the value is, it will give you 1 minus 2, which is minus 1, but absolute value you have to consider because there is modulus, so it will give you plus 1. Similarly, 3 minus 4 modulus will give you 1. Here 3 minus 3 is 0, so it is again equal to 0, so it is satisfying, and every single element, whichever way it is related with other element, is giving this relation. So this is the definition of universal relation. Okay, that means each element of A is related. If the relation is going from A to A, that means first element of order pair and second element of order pair both are from A. So that means what it is, each element will come under this category. So universal relation. Okay. Now another one is reflexive. So what do you mean by reflexive? What do you mean by reflexive? So if I ask you that you have the relation T1, T2 with you, where this is the set of triangles. So it has been taken from a universal set where T is the set of all the triangles, be it scalene, isosceles, equilateral, whatever. So this is a relation. Okay. Now what is reflexive relation? So reflection, that means the object itself is there, right? Reflection means exactly same. So when you consider T1 and T1 as ordered pair, can you think that if you are taking this order pair, then obviously same thing will be congruent to itself? So that means T1 belongs to R. So whenever there is such type of condition, it is called reflexive. Okay? Same elements are related with each other in the odd form of ordered pair. Okay? When we say symmetric, that means if you are considering T1, T2, let's say let T1, T2 belongs to R. What does it mean? T1 is congruent to T2? So can I write it in the converse form that T2 is congruent to T1? Same thing, right? I'm just switching the sides. So this means T2 and T1 are also related with R. And hence, whenever there is such condition where you are considering A, B as order, but you are getting B and A as order. That means commutative form, sort of. So that means this relation is symmetric. Okay? Then we have another one which is called transitive. So what we do in transitive? We consider two elements, two ordered pair. Let's assume T1, T2 belongs to R as well as T2, T3 belongs to R. Okay? What it is? T2 and T3 belongs to R. Make sure you have these two elements common. Alright, so what it will give you, if T1 and T2 belongs to R, this means T1 is congruent to T2 as per the definition of this relation. If T2 comma T3 belongs to R, that means T2 is congruent to T3. But T2 is congruent to both T1 and T3, that means T1 and T3 are also overlapping figures, congruent to each other. And this states that T1, T3 belongs to R. Hence, R is transitive. Correct? Make sure you remember this. You are considering two ordered pair having T2 as common, and then you are getting the third one. So this is transitive. And what is equivalence relation? When there is one relation which is reflexive as well as symmetric as well as transitive. So when all these three conditions are satisfied, then the relation is equivalence. Hope you understood.